Hello and welcome to my channel Hardware.ai. Today we're going to be talking about the hardware specs of Google Coral development boards, which I have right here. So let's start by opening a box. It's a fairly simple in design box. I think it's made of recycled material, and the first thing we see is the short manual with the pictures of the board and its interfaces. And also right here it says Google's AI principles guide all of our work. We hope they will guide your work too. And they want us to have a look at those principles. I guess it says something like, don't make killer robots with this board. Other than the short manual, there is nothing else inside of the box except for the development board itself in a simple electrostatic bag. So here it is. Let's start with the basics. On the top left corner we have 40-pin Raspberry Pi compatible GPIO pinouts, and despite it's Raspberry Pi compatible, for most of the heads you will need to get the extension, because system on module occupies quite a lot of space, so it won't be fully compatible with Raspberry Pi heads. Next we have the serial console, which we can use to access our board, and we will also use it in the flashing process. Next we have USB 3 Type A host right here, which can be useful for connecting peripherals. Gigabit Ethernet port right. Next one is a little bit more interesting. This one is 4-pin terminal for stereo speakers, which is quite neat. Basically it means that you can just wire stereo speakers directly to those screw terminals. Next one is the reset button, nested right here. This is an audio jack, standard audio jack. Next we have two USB Type-C ports, one for power. This one is for power, providing the board with 5 volts and 2 to 3 amperes power. And this one is OTG USB for connecting to other peripherals or connecting to your computer. Here we have a full-sized HDMI port for connecting to the monitor, but actually in most of the cases you won't need to connect your board to a screen, because you can do lots of stuff using the SSH. And on the back of the board we have SD card slots. Since the board has 8 GB of memory, internal memory, we don't need to use SD card for boot like we do with Raspberry Pi, but it supports booting from the SD card. Other than that, on the back we can see one CSI2 camera connector and DSI display connectors right here. For quick size comparison, let's have a look at the Raspberry Pi right here. Here's side-by-side comparison, fairly similar in size. And then we have comparison with Jetson Nano development board right here. So here's 3 of them side by side, and you can see that Jetson Nano is indeed slightly bigger, but that's just the development board, the expansion board. What we want to do next, we want to remove the heatsink and the fan and have a look at the system on module itself. And this is NVIDIA module, system on module without the heatsink. The system on module itself is just this big, with the heatsink on top of it. On the bottom there is a row of connectors which connect it to the carrier board here, or if you're making your own project, you can obviously design your own carrier board. And the connector, the details about the connections are all in Google's manual, and I had a look at it. It's very detailed. In the system on module, we have the quad-core Cortex A53 processor, and we have Cortex M4F for low power operations. We also have a graphic processing unit for mobile graphics, which is Vivante GC7000 Lite. There is 1 GB of low power DDR4 memory and 8 GB flash memory. Well, and here they are, back together and in one piece again. Hopefully working normally. I haven't tried them yet. Alright, so that was the end of our hardware review of Coral Development Board by Google. And I will make the third part of the series talking about the general overview of the Google Coral Development Board somewhere next week. See you then!